So I'll start by introducing myself. My name is Katie Bagnall-Newman. I am the Associate Director for Nature Center Programs here at the Paleontological Research Institution and its Cayuga Nature Center. And I'll let Ingrid introduce herself.
Thanks. So I'm Ingrid Zabel, and I'm the Climate Change Education Manager at the Paleontological Research Institution, which includes the Cayuga Nature Center and the Museum of the Earth.
Thanks, Ingrid. So today we're just going to talk a little bit about sugar maples and climate change. So I'll get us started by just talking first about, there we go, sugar maples. So most folks in Northeast US are relatively familiar with the sugar maple. Its scientific name is Acer saccharum, and it is also called many things, including hard maple, rock maple, or bird's eye maple. So lots of different common names. The one that we'll hear most frequently is the sugar maple. The other northeastern maple species that we see very commonly are going to be the red and the silver maple, which have different leaf shapes. So the sugar maple grows to be a relatively large tree, over 80 feet tall. There are some as tall as 150 feet on record, and they can live over 300 years old. I believe the oldest recorded one is in the 500s, so that's pretty long. We also they have the very well-known paired winged seeds. They do produce seeds every year, but they'll have larger production on a 2 to 5 year cycle. And then in the fall, they turn these beautiful shades of red, orange, green, yellow, and every color in between. So they're a very beautiful fall tree. They're used for maple syrup products, flooring, paneling, musical instruments, baseball bats, landscaping, and more. One of my favorite things that we see going on is sugar maples being used more frequently for baseball bats now that there is less ash. So baseball bats are historically made out of white ash in particular, but due to the emerald ash borer, which is an invasive species, kind of wiping out some of those ash trees, there's a lot less ash being produced. And so maple or sugar maple is a really good substitute for that because it's a very hard wood. And then in the ecosystem, it's also very important for various animals. Some of the big three are going to be deer, rabbits, and moose. They'll eat, especially the young saplings, are really tasty to them, and they'll browse pretty heavily on that. And then I just wanted to show everyone a map. This is a nice view of its range. So you can see that here in New York, pretty much anywhere in the state you can find sugar maple, and has a range pretty far north and pretty far south. We've even got some outliers down in the south here of different sugar maple populations, as far south as Georgia. And then there's also some in South Dakota and North Dakota as well. So it reaches pretty far. They, however, don't have a super high tolerance of pollution, soil acidification, heavy salt spray from the roads, compacted soils, or high heat. So they were actually used a lot more commonly for landscaping in the past, and you would see them planted in yards, parks, homes, and they're starting to actually be replaced by the Norway maple, which is a non-native species that is planted. Looks very similar, but it doesn't have the same vibrant color in the fall. But we have replaced it a little bit and are shifting towards that continually because of the low tolerance of the sugar maple. So it doesn't make a great city planting tree anymore due to the fact that there's just too much compaction in the soils and a lot of salt used on our roads. And then the sugar maple has, so the reason we're talking about it today for Maple Week is because it's very important to humans and animals, like we mentioned before, but particularly for sugar maple or sugar maple syrup making. So maple syrup is made from the sap of the sugar maple tree. It can also be made from other maples. However, the sugar maple has double the sugar content. So about 2% of the sap that we collect is sugar. And so any other maple is going to be about 1%. And so that 2% really gets us to boil a lot less sap in order to get the syrup that we're looking for. Even though it has a higher sugar content, it's still a 40 to 1 gallon ratio. So 40 gallons of sap about will equal 1 gallon of syrup. So that's still a lot of boiling that we have to do in order to get maple syrup. And a single tree can produce 5 to 60 liters of sap per year. And on a good day, like today, we've had a relatively cold night and we're having warm days. That's when we get the most production out of our maple trees. And we'll get a full bucket in a day on a good day. So you can see the buckets there are pretty large. They're about they're a little over a gallon buckets. So we can get quite a bit of sap in a relatively short period of time on a good day. And then we had a question just to ask folks. And if you want to put your answer in the chat, we would love to see what your favorite sugar maple product is. So this could be syrup, cream, sugar candy, or maybe there's something else out there. Got a couple syrups, one cream. Nice.
And if
Looks
you're
like
having, I was just going to say, if you're having trouble typing in the chat, you could just unmute and speak up because we don't have a huge group here.
All right, so it looks like maple syrup won. And
there's another maple cream.
oh, nice.
They're all good. So I'm going to talk to you a little bit about climate change and as it's related to sugar maples. And I'll start by showing you some climate data so you can see what's been happening here in Tompkins County. Though I should say, of course, sugar maples don't just grow here, right? They grow in the Northeast, in the Midwest, in Canada. And if you looked at climate data from those broader regions, certainly if you looked at any other county, you'd probably see something different. Every place has its own climate record, but the general trends I'm going to show you are reflective of what's seen in the broader region. So these are some historical observations. And what I'm plotting here is average annual temperature in Fahrenheit over time, going from 1970 to 2020. So the last 50 years. And each data point here is an annual average. So what that means is you take, for a given year, you take, let's say, the average temperature of each day, and then you average together all of those 365 days in a year to get one single data point. So we're averaging together for a single year, winter and summer and fall, and spring temperatures. And that's why these numbers are what they are. You see numbers in the mid 40s for this part of the world. And two things I noticed in this graph. One is that the annual average temperatures fluctuate. They go up and down. So that tells you that weather is variable. So some years are really warm, like this was 2012, which is an exceptionally warm year around here, 2016 also. But then we had some really cold years. So 2014, 2015, those were years when we had those brutally cold winters that you might remember a few years ago. So weather varies from year to year. If you want to look at climate trends, you have to look at least 30 years or more to say if something has changed in the climate. And that's what we do see. So we do see this trend over these 50 years of increasing temperatures. And the rate of that trend line is about 0.4 of a degree Fahrenheit per decade. So if you do the math over these 50 years, that's about a 2-degree increase in temperature. And just so you're not confused, you may have heard on the news talk about wanting to limit the Earth's temperature rise to 2 degrees from pre-industrial times to the end of this century. But that number, 2 degrees, is always given in Celsius. So here I'm talking Fahrenheit. So we haven't reached that 2 degrees Celsius in this short time. This is 2 degrees Fahrenheit that we've seen, but we are seeing an increase. So our climate is changing. And now on the next slide, I'm going to show you projections into the future. So here I've taken that same graph that I just showed you with these red data points, and I've moved it over to the left and sort of smushed it because I've increased the temperature scale. And then on the right, I've included projections of how our climate might change in the future going to the end of this century. And you see two regions, these pink and blue regions. Well, let me start with just generally, if we look at the blue, you see there's sort of a broad range. So that's because what I'm showing you here are the results of 32 different climate models. So these are numerical models run on a computer to project future climate. And they each give a slightly different result, though they each show the same trend. But that's why, since they're each slightly different, you get this range of results. And the dark line you see in the middle is the average of all those 32 model runs. And the same for the pink region. And then the difference between the pink and the blue is that if you think about what goes into a climate model, well, we put in the best scientific understanding we have of the physics and chemistry of the atmosphere and the Earth's climate system, but we also put in human actions. So we put in what we call emission scenarios, and these reflect the choices that we make in terms of how many greenhouse gases we put into the atmosphere that warm the Earth. So the pink is what's called a high emission scenario, and that's where we kind of keep on doing what we're doing now. So spewing out a lot of carbon dioxide that's heating the Earth and not really making changes. The blue is what we call a medium or low emission scenario, where we do a pretty good job at cutting our greenhouse gas emissions. And they would peak by around the middle of this century and then start to decline going towards the end of the century. So in that case, you see not as much warming in the blue as in the pink. But in both of them, you do see warming. So both of them project that by the end of the century, the average annual temperature in Tompkins County will be either 52 degrees in the lower emission scenario or 57 degrees Fahrenheit in the higher emissions. And you can compare that with, again, back in 1970, the average temperature was around 45 degrees. So, very significant changes. And I just want to highlight too that, again, that these are not predictions of what are going to happen. This is what could happen, but we can choose to not go there, right? We can choose to cut our emissions, and then these changes will not be as large. All right, so now with that background, let me talk about what some research has found about the impact on sugar maples. So this is a study that was published in 2009, and it was done by faculty at Cornell, actually. And they looked at the effect of temperature changes on sap flow in sugar maples. And what they did is they analyzed data from climate models together with physiological information about sugar maples. And they were able to model the number of days in a year when sap is flowing. And they did this going back into the past, and then to verify their model by comparing it with data, and then they ran the model into the future. And they found that if we stick to our traditional schedules of when to tap sugar maples, we're going to lose tapping days in the future because there'll be fewer days when sap is flowing. But if we move the tapping season back about a month, so they found about 30 days, to the colder part of winter, we won't lose tapping days even by the end of this century. So essentially the sap flow season is shifting earlier in the year to the colder part of winter. Unfortunately, though, eventually they said as temperatures continue to rise past the end of this century, that way of adapting our practices won't work. And that sap flow season could move so far back that it bumps into the end of late fall and we'll lose tapping days. This was another study published just last year, and it looked at not just temperature, but other factors that affect how sugar maples thrive. So some studies have suggested that sugar maple habitat is going to expand northward because of warmer temperatures. So right now we're here in this eastern mixed forest region, and to the north of us up in Canada is this boreal forest. And this study looked at not just temperatures, but also soil chemistry and other organisms in the soil. And they found that the types of nutrients and fungi that sugar maple seedlings need are not really found in the right amounts in this boreal forest soils. So sugar maples, even though their habitat may be moving north because of temperature, they may be constrained by these other things from moving too far northward. So I think that's an interesting result too, and points to it. It makes sense that we have to consider all these factors, not just temperature. All right, so we're just going to stop for a minute and ask you, what climate changes have you noticed where you live, or maybe heard other people talk about? And again, you can type your answers in the chat or just unmute and speak up if you'd like to. Let's see, I have to bring up my chat so I can see it here.
Looks like we've got one answer of extreme weather.
Mm-hmm. Definitely. So more extreme hot days, more extreme storms. More storms, they seem worse. Also either much warmer or colder winters. Mm-hmm. Yep, hotter summers, more frequent record temps, definitely. Warmer winters and less snow. Bigger storm events, yep. Yeah, and I think all these things that you are saying you have noticed are things that we're seeing in the data as well. So it's not just your imagination. More flooding, yes, absolutely. And we're getting more heavy rainfall events, plus on the coast, sea level is rising. That's leading to more flooding. Yep. All right, so I'm actually going to talk about one of those changes that people mentioned and in relation to, actually two of those in relation to climate change, but let's look at snow. So again, this is local, and for snowfall data, it's hard to find for sort of county or state or regional levels, but you tend to find it for individual weather stations. So this is a data set from a weather station on Game Farm Road that Cornell runs, and it's been operating for a long time. And here I'm plotting, again, for that same time period, 1970 to 2020, total annual snowfall in inches. And what you see is a downward trend. So we've been getting less snowfall. That's something, I grew up in Ithaca, and I feel like I remember that, though I've always wondered, is that just because I was smaller back in the 1970s when I was a kid, so those snowdrifts seemed higher to me? But the data show that it reflects what I remember. And that rate of decrease is 3.4 inches per decade. So if you do the math, then think of over these 5 decades, that adds up to almost 1.5 feet less snow now than in the 1970s, which is really significant. All right. And here's some research. This is a study from 2018 that looked at the effect of snow cover on sugar maple growth for sugar maples that do grow in snowy areas and cold areas. So what they did was they did some experiments in a forest. Here it's this Hubbard Brook Experimental Forest in New Hampshire. And they manipulated the snow around sugar maple trees. So basically snow would fall, but then if they wanted to test what happens when there's reduced snow cover, they would brush it away from these trees. And they did this over several years. And they found that when you have reduced snow cover or snowpack, the trees don't get that nice thermal insulation from the snow. And so the soil freezes more easily. And that can affect the roots of sugar maple trees, and it can reduce their growth pretty substantially. And so here you see some plots. This first plot on the top left is the likelihood of having an insulating midwinter snowpack in the second half of the 20th century. And then below that, they have how that is predicted to change for the second half of the 21st century. So you see the shift from less blue, which means less snowpack. And then on the right, here they're showing current sugar maple distribution, and where it's dark green, you're finding more sugar maples. And then below that, they're looking at some changes in these areas that are influenced by snowpack and seeing that is maybe constraining how sugar maples will thrive in the future, and less likely to find good habitat. Again, not just because of temperature, but because of changes in snow. All right, and then one last climate change I wanted to talk about. And this one, I'm going to talk about not so much the impact on the trees themselves, but on producing maple syrup. So we have been getting, as someone mentioned in the chat, more heavy rainfalls. So heavy rainfall means a large amount of water falling in a short time. And this is from the 4th National Climate Assessment, and it's a map of percentage change in heavy rainfalls from the middle of the 20th century to around now, 2016. And what you see is in most areas of the US, except for here you see Hawaii, and actually I don't remember if that's Guam or Puerto Rico that they've put on the map. But most of the US, including Alaska, have seen increases in heavy rainfalls. And the highest percentage increases have been where we are and where sugar maples grow. So in the Northeast and the Midwest, we've seen a 55% increase in heavy rainfalls from 1958 to 2016. So how might this affect how we make maple syrup? Well, if you think about it, not the trees themselves, but this is a sugar house. So this is where the sap comes in and is boiled and processed to make the syrup. And in commercial sugar maple production, they will often use these tubes connected to the trees that will bring the sap from the trees down to the sugar house. And the best place to locate the sugar house is down at low elevation because you want to take advantage of gravity to pull the sap and have it easily flow in those tubes down to the sugar house. So it's the best place for sap flow, but it's the worst possible place for flooding at low elevation. So as we're getting more and more heavy rainfalls, these sugar houses are more at risk. And we see that at the Nature Center, right? Our sugar shack is down low. And Katie can speak to that on some past rainy years. So interesting to think, I think, about how climate change is affecting our practices as well as just the biology of trees. And I did want to mention that this image and this story came from a set of videos from a really nice Cornell site called Climate Smart Farming. They have many different videos on the impact of climate change on farms in the Northeast, especially New York State. And this was one of their videos about maple syrup production. So I recommend you go there and watch some of those videos. All right. So now I will, we have another question, and I'll let Katie lead you through this one.
All right, so for this poll question, we wanted to ask which of these 3 sources of sugar has the most sustainable type of production? The sugar maple tree, sugar cane, or sugar beets? So yeah, you can go ahead and put your answer in the chat or shout it out. I'll also be curious to see if anyone wants to explain why they think that, or talk about their reasoning at all, that would be great as well. We got some guesses for sugar maple.
Mm-hmm.
So does anyone want to, sugar cane due to warmer climate? That's a good guess. Beets, perhaps. Okay, so we got a guess for each one.
Mm-hmm.
All right, so I'll talk a little bit about the sugar maple. So sugar maple is a good guess and is arguably the winner. I arguably for sure, but they are, like I mentioned before, old living trees, so they can live, 300 plus years. So you only have to plant them once. You never have to spread any fertilizer. You never have to rotate the soil, replant for 300 years. So they live a long time, and they take very little care. You don't have to tend to them like you would most crops. And harvesting is relatively simple as well. So you can see that we do have the tubing all set up, so that does have to get set up each year. Or some people might leave them up but take the tap out of the tree as well. So that's something that takes a lot less energy and arguably less equipment as well to harvest. And then during the boiling process, either wood can be burned, or a lot of commercial places will use propane as well as an RO system in order to really efficiently get the sap down into syrup. So that's certainly a really great option, and is a very sustainable practice. And obviously it's still imperfect like most things. We are using plastic tubing. You do have to replace the materials. There's still some equipment involved, but relatively it is a very sustainable choice. All right, and then we wanted to kind of end our presentation talking a little bit about what we can do. So one of the first things that I did want to mention was if you live in New York State, the DEC, the Department of Conservation, has a wonderful program where you can buy trees in bulk. So the Nature Center has participated in this program, as have other CNC staff, where we will purchase large amounts of trees in order to plant. The tree that you can see in the picture is a white cedar, which isn't very common naturally in New York State, but they are really great for certain areas, such as where this one was planted alongside a stream bed. The roots are really good at holding in the soil and growing on little soil as well, so they help a lot with erosion. But you can buy sugar maples and a lot of other different tree species. So it's not too late to plant sugar maples. You can still plant them. It might change in the years to come, but I wouldn't say not to plant them. But you can get large amounts of sugar maples or any other tree at that website for relatively low cost. And that's for any New York State landowner or organization such as the Nature Center. You can also, there are some resources on the DEC website to look into what trees to plant for climate change. So there are specific tree species that they are anticipating will do really well with the future predicted changes in our climate. One of the ones they're actively researching that I find really interesting is the Kentucky coffee tree, which might, they're not sure yet, but the thought is that it might become a really great planting for this area in the next 50 years. You can look all that up, like I said, on the DEC website, and I can actually copy and, oh, that's not what I wanted. In a little bit, I'll make sure to throw that in the chat. Oh, Ingrid already did. Perfect.
Yep. All right, yeah, and another way you can get involved is in contributing to science. So there's so much that we still don't know about sugar maples, about trees, and how they respond to climate change, and that we really need to learn to help ourselves and to help ecosystems adapt to climate change. So one way you can participate is in a citizen science or community science project on tree phenology. So phenology is the study of seasonal and cyclical changes in animal and plant life, and as it's connected to weather and climate. So this is studies of things like the timing of when leaf buds open on trees or when birds migrate. And we have a tree phenology trail at the Cayuga Nature Center. It's a set of 5 trees that we've marked for observations. You see here a sugar maple in 3 different seasons, and there's a little marker on it. And we observe those trees and we send the data to a place called the USA National Phenology Network. And this is their website, usanpn.org. And they have a project called Nature's Notebook where anyone can pick a tree and make these phenological observations and submit them. And then scientists use that data. So if you want, you can come out to the nature and observe our trees, or you could do this at home. You could pick a tree in your yard or your neighborhood and sign up with the National Phenology Network. And they have a phone app. I'm showing a screenshot of it here where you make the observations and submit them. And I'll mention also on May 1st this year, I'm giving a guided phenology walk of our trail. Well, I'll talk about what phenology is and the history of it and what we're learning, and you can learn how to make those observations. I'll teach you how. All right, Katie, next slide, please. This is another community science project called COCO-RAS, the Community Collaborative Rain, Hail, and Snow Network. So this is another way that you can contribute to climate science. Basically, it's a very nice, simple project where you get a rain gauge, like this one shown here, and you measure daily precipitation, so rain and snowfall, and then you submit it to this network. And this is a map from a few days ago showing everyone's observations. Each of these dots is someone's observation across the country. So it's really nice because you get instant feedback. You submit your observation and then you can see everyone else, and you really feel like you're part of this community who are making these measurements. And they're very important because they fill in gaps in between where the National Weather Service has weather stations. So they really are meaningful measurements. All right, and next slide, please. And then finally, if you're concerned about climate change, as I am, there are actions you can take to try to reduce it and adapt to it. But here I'm focusing on reducing it. So number one is find ways to use less energy. And I don't mean to put this on individuals. We can do this as individuals, but of course we need to do this as a society too. Use less energy, but also use forms of energy that release fewer greenhouse gases. And these are some examples of low carbon energy sources. So electric vehicles, as long as they're charged with electricity coming from low carbon sources. And New York State is moving rapidly in that direction. Solar energy, wind energy, hydropower, geothermal energy, both shallow and deep. So shallow might be something like a ground source heat pump that you could use to heat and cool a building, or deep geothermal energy like Cornell is planning for a campus. And nuclear energy is low carbon. Nuclear energy has its own issues, but it is low carbon, so it's important to think about. And I mentioned here, I'd show this picture of community solar because it's something that a lot of people can participate in. So even if you don't want to or can't put solar panels on the roof of your home, Maybe you can't afford that upfront cost, or maybe you rent your home and the choice is not up to you. You can still subscribe to community solar and it's really growing in our region. And I just put a link. I know this link is link is too much for you to copy, but I just wanted to emphasize, if you want to get information about that, a great source is our local cooperative extension of Tompkins County. They have a lot of good information about how to sign up for community solar, how it works, and so on. So I will end there and say that climate change is certainly affecting sugar maples, but there's a lot we can do about it. Well, thank you for joining us today.